Hi everyone, this is Morgan here with Positive Approach to Math. We are moving right along in our equations topic. We have been solving equations for the past couple lessons, but now we're going to amp it up and put a variable on both sides of that equal sign. So everything that we've done thus far is going to still come into play. We just have to make sure we get our variable all to one side so we can solve for that variable. So let's take a look at some of the key information here as we start this process. So when we get to these more complex equations, we want to make sure we simplify both sides of that equal sign. So we want to work to make sure we apply the distributive property where we might need to, and then combined like terms on each side. So a lot of times you'll see me say, okay, can we simplify the left-hand side? Let's do that. Can we simplify the right-hand side? Okay, let's do that. So we get it down to a variable plus a constant. Something along those lines. We want to get that on both sides. Then what we're going to do is we want to collect all of our variables on one side of our equation. So a lot of times if you see it on the left and on the right, you can move it to either side. I always say letter to the left. So I like to take my variable that's on the right and I move it over the bar or over the bridge to the left-hand side. Remember, when we move something over that bridge, we're going to perform the opposite operation. So we're either going to add or subtract it. We're going to do the opposite of whatever is there. We're going to apply the inverse, okay? Once we do that, you're going to see it's now in the setup for a two-step equation, which we have down pat. So then we're going to work to solve for our given variable using our properties of equality. Work to get that variable by itself, and then we're good to go. And as always, we can check our work. So let's jump right to it here. I'm looking at these examples. I'm going to slide this up just a teeny tiny bit right there. Okay, just a friendly reminder that you are more than welcome to download the PDF of this lesson in the details below. There is a answer key to the U-tries, and there is a video to the U-tries. So whatever you need, you can find it in those details below. Please use all of those resources to help you. So our first example, we're still following through with what we've been doing of putting that orange bridge down our equal sign. And the same concept still applies. If I do one thing to one side, I have to keep it balanced and do it to the other side. If I'm moving something over, I have to do that same operation on both sides. So I'm going to look at that left-hand side, and I'm going to say, okay, I don't see any parentheses, no distribution needed, and 5x and 18 are not like terms. So there's nothing to combine on that left-hand side. Now I'm going to look at that right-hand side. Same thing, no parentheses, no need to distribute, no like terms to combine. So we're good to go. Here's the issue. We have an x on the left and an x term on the right, and we want to be left with one term that has the variable x. So we need to bring our like terms all to one side. So I see that I have a 5x here and a 3x here. Ooh, I like it to be circled. There we go. And so I want to move one of them over the bridge. I like to personally move every variable to the left, letter to the left. So if I can. So I'm going to say, okay, I need to take that positive 3x and I want to move it over to move that 3x over to the other side, we're going to subtract it. Okay? And if I subtract it on one side, I have to subtract it on the other side. And I'm going to make sure I align it with its like terms. Okay? So 5x minus 3x. That's going to simplify down to 2x. I didn't do anything with that plus 18, so I'm going to draw my arrow to make sure I know to just bring it on down. And then I didn't do anything with that positive 40, so once again, I'm going to just draw an arrow. And because that's the only term on the right, I can just write 40. I don't have to write plus 40, okay? As you see from here, this looks like what we've been boiling everything down to. We're in our two-step final process of our equation solving. So I'm going to put that 2x in a box. You know the drill from here. I'm going to move a little bit quicker when we get to this two-step process because it should be familiar with you. I'm going to subtract 18 on both sides, right? I need to move over that plus 18. The opposite of addition is subtraction. I'm going to move that 2x down. 40 minus 18 is going to give us 22. And then we have 2 times x, so we're going to divide both sides by 2 to get x all by itself, and we get x equals 11, okay? Now, same thing that we've been doing all along, you can plug that 11 in for the x on the left and for the x on the right, and make sure when you boil it down, you get the same thing on the left and the same thing on the right, okay? So that was our first problem, just showing you how to move a variable over to the other side. A lot of times you're either going to add or subtract when you move a variable term over to the left or to the right. Okay, second example, looking here, I see parentheses on the left, so I'm going to take care of those. I'm going to distribute. So remember, there's like a 1 in front of that x, so we're doing 4 times 1, which will give us 4x. And then 4 times 8, which will give us a positive 32. On that right-hand side, there is no distribution, no parentheses, so I'm just going to bring it down. In fact, on that right-hand side, there's no like terms that I can even combine, so the x is going to come down and the minus 7 will come down as well. Okay, now look at that left-hand side after we distributed. Are there any like terms? So I'm looking for like terms just within these two things, right? So it's divvied up by that bar, that line, that bridge. So I'm only looking for like terms on that left. 4x, 32, not like terms, nothing to combine. Look for your like terms on the right of that bridge. X, 7, not like terms, nothing to combine. So now we want to get all of our variables on one side. So what I'm going to do to help us out here, I'm going to write, because remember in front of that x there's really like an invisible 1. So I'm going to put that 1x there, and it's positive 1x. So I want to do the inverse operation. So if it's currently being added, that 1x, I'm going to want to subtract it to move it over the bridge. We do the opposite operation when we move things over our bridge. So that's going to go away on the right. 1x minus 1x will go to 0. 4x minus 1x will leave us with 3x. We're going to bring down the plus 32. And we will bring down the negative 7. And would you look at that? What did we boil it down to? Our two-step solving process. So from here we can put that 3x in our box. We are going to get rid of the thing outside of the box, minus 32. Okay, bring down that 3x. That gives us negative 39, and let's see if I can squeeze in this last step. That's 3 times x. So then we're going to divide both sides by 3. Can I squeeze it in? Now, please pay attention. We are doing negative 39 divided by positive 3, which will give us a negative 13. Okay, and you can go ahead and you can plug that in if you wanted to check your work. All right, I'm going to slide this down a little bit more. We've got 3 more problems to do. Okay, let's look at that third example. That looks really, really intense, but I think it's going to be really fun. Okay, so looking at this third example on that left-hand side, right away, I do spot parentheses. So I am going to distribute that 3. Remember, we distribute to everything in parentheses. So it would be wrong to send that 3 to negative 4x, right? That negative 4x is just coming along for the ride right now. So 3 times 2x, whoopsie, let's slide that back up. 3 times 2x will give us 6x. And 3 times negative 5 will give us negative 15. And then if it helps you, just put your little arrow. We're going to bring down minus 4x. And I did put it a little far to the left, but that's okay. Looking at that right-hand side, there is no distribution needed there. If you want to take a look and say, okay, looking at that right-hand side, do you want to go ahead and combine like terms right away? You can do that. I'm going to combine like terms all in one step here. I'm going to combine the like terms on the left-hand side, and then I'm going to combine like terms on the right-hand side. So let's look at this left-hand side. Do we see, so we're only looking at things to the left of our bridge. On the left, do we see anything we can combine or simplify? And remember, if we are simplifying within the same side, we keep the operation the same. So I see 6x minus 4x. Those are like terms. So I'm going to smush them together. I'm going to do 6x minus 4x. I'm not changing any operation because I'm not moving anything over the bridge. It's all staying on that left-hand side of the bridge. So 6x minus 4x will give us 2x. We're not touching that minus 15 because it doesn't have any friends to combine with. So we're just going to draw our arrow so we know to bring it down. Okay. And now we're going to look at the right-hand side. We'll put that in pink. So looking at that right-hand side, we're going to say, okay, do we have any like terms on this right-hand side? And we see we have two constants. We have a 3 and a positive 2. They're both on that right-hand side, so they're on the same side, so we can simplify with the same operation that we see there. So all we're going to do is we have positive 3 plus 2, which will give us 5. And this negative 3x we will bring down. Now, it would not be wrong if you wrote negative 3x plus 5. Doesn't matter which one you put first. Just make sure that negative goes with that 3x. Okay, so we have no more like terms on the left to combine, no more like terms on the right. But now we have our x term on the left and on the right, so we want to move that x term all on one side. So I'm going to stick to my plan of moving the minus 3x over to the left, letter on the left. I'll show you one where we move the letter to the right, just in case you ever feel like living on the wild side. But that minus 3x, the opposite of it would be to add 3x. And it's really, really important to show nice, neat work and make sure you're aligning things so you don't confuse yourself, okay? It's really easy to get lost in your own work if you kind of put it all over the place. So 2x plus 3x will give us 5x. Sometimes people like to put even like lines like that to kind of help them. Minus 15, bring it on down, and we're left with just that plain old 5. So as you see in this line here, I either put something that I'm doing or I put an arrow so every value is accounted for. And now from here, easy peasy lemon squeezy, 5x in the box, opposite of minus 15, got to get rid of that, plus 15, you should be a pro at your two-step equations. Oh, and once again, I'm probably going to run out of room. And then the opposite of multiplying by 5 is to divide. And 20 divided by 5 will leave us with 4. And I'm going to move that answer because we have another example. So we'll squeeze it right there. Okay. Good stuff. So that was where we had a little bit happening on both sides and a lot of simplifying to do beforehand. Let's look at this fourth example. It's kind of the same thing, but there's distribution on both sides. So I'm going to draw a really long line down that equal sign. I see parentheses on the left, so I'm going to give that a distribution. Remember, to distribute means to multiply. So we're going to have 3x minus 12. That plus 2x just gets brought down. It comes along for the ride. And on that right-hand side, I have a 5 to distribute. So hopefully it's not blending in too much here. I can lower it a little bit with that previous problem. 5 right? So we're going to have 5 times x, which is 5x, 5 times negative 4, which is negative 20, and we're going to bring down that plus 8. Cool. All right, we're looking just at our left-hand side. We'll do different colors for our highlighter here. Just at our left-hand side, do we see any like terms that we can combine? And we see a 3x plus a 2x. That is going to leave us with a 5x. Okay, we're going to bring down that minus 12. And then we're going to look at that right-hand side. Do we see any like terms? Remember, when we're combining on the same side of our bridge, we keep the operation the same. So I do see negative 20 plus 8. So that's what you're combining. If you were using your calculator, you would punch in negative 20 plus 8. Do not switch any of the signs. The 5x is going to come down. Negative 20 plus 8 will give us negative 12. Maybe you're noticing something here. Maybe you're not noticing, but something special is going to happen in this next step. So now you're thinking, okay, I got this. We've been doing this for the past 3 examples. I need to move my letter to the left, blah, 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 right? So we're going to move our 5x over to the left, and it's a positive 5x, so we're going to subtract 5x. But notice something happens here. 5x minus 5x on the right will cancel because that's going to go to 0, but it also goes to 0 on the left because it's 5x minus 5x, which will go to 0x. And remember, we don't want to write 0x because 0 times x is just 0, so it wipes out that entire term. So we're not left with a variable here. We have negative 12 on the right, and we have negative 12 on the left, or on the left, and we have negative 12 on the right. Woo! So we have negative 12 on both sides, regardless, right? And the issue is I don't have a variable to isolate. So now you're probably thinking, well, then now what? How do we solve if we don't have a variable to solve for? And here's the thing. When your variable on the left and right both go to 0x or 0 whatever your variable, they cancel on both sides, you are left with either all solutions, meaning every real number you can think of in the world will satisfy this equation, or you're left with no solution. So no matter how many values you try to substitute in for x, none of them are going to make this statement true. And here's how you know. So once you get rid of those x's, you're left with 2 numbers equal to one another. You need to ask yourself, is that true or is that false? Does negative 12 equal negative 12? Are they equal to one another? And the only time 2 numbers are equal is if they're the exact same number. And so in this case, yes, that is true. So when we have a true statement, that means we can pick any real number for x and it will satisfy this equation. So that means that there are infinitely many solutions. And we like to write that. Sometimes I have my kids write IMS. Right? Some other things your teacher might have you do, let's squeeze an S there, is they might tell you all real numbers will satisfy this. Meaning you can pick any real number, 3, 3.1, negative 3.1. You can plug it in and it should work and make the left-hand side and right-hand side equal. And sometimes to represent that all real numbers is we use this fancy R. That's the set of all real numbers, meaning every real number will work, not just 1 or 2 of them, all of them. So when your variable on the left and right cancel, you're going to go into a true-false scenario. True means every value works for this, every real number works, and hopefully you can imagine what false would mean. So it's like an all or nothing sort of deal when your variable cancels. You cannot solve, and you should not be writing x equals when they cancel on the both sides. You're going to compare the 2 numbers and tell me if it's true or if it's false. Okay? So let's try one more. Let's scroll here, okay? So looking at that left-hand side, let me draw my line down. I see I have to distribute. Remember, we cannot combine that 7 minus 2 first. That minus 2 is attached to those parentheses. So you have to set it free from being attached to those parentheses. So you have to distribute that negative 2 to the x and to the 1. So that 7 gets brought down. That's going to become minus 2x, and that's going to become minus 2. Okay? There's no distribution happening on the right-hand side, so I'm just going to, for now, bring everything down. If you want to try to combine like terms right there, go for it, right? I'm going to do all my combining like terms in this next step. Okay, left-hand side, do we see like terms? Left-hand side, so we're saying everything on the left, they're on the same side. Like terms simplify with the same operation. And we see 7 minus 2. That's going to give us 5. And I'm going to bring down my minus 2x. Remember, would not be wrong if you put minus 2x plus 5. Okay? Looking at that right-hand side, I'm going to right now put a little 1 in front of that x. That's the invisible 1. I do see like terms. I see 1x minus 3x. I'm going to combine those. Same side, same operation that I see. 1 minus 3 will give me negative 2. And I'm going to attach the x. And then I'm going to bring down that minus 2. Can't forget my equal sign. Okay. Now I'm going to move my variable over. I need to get my variables all on one side. So I'm going to take that minus 2x on the right, and I'm going to move it over by adding 2x. And because I'm moving it over the bridge, I do the opposite, O and O. So I'm going to add, okay, negative 2 plus 2 will go to 0. They will cancel, and it's going to cancel on both sides. So what we're left with is we're left with 5 equals negative 2. We don't have a variable to solve for. So we need to train our brain when there's no variable left to solve for. It's all or nothing. All solutions will work, infinitely many, or none, right? So if I have 5 equals negative 2, you have to ask yourself, I have two numbers. Is that a true statement? Does 5 equal negative 2? And hopefully you're thinking, heck no, right? So that is false. So when we have a false statement, it means no solution. No possible value that you think up in your mind will work when you plug that in. You can try every single number that you can think of, and none of them will make that statement true. And so we can write no solution, or a lot of times kids love to write the empty set. And that empty set is translated, it's saying x is in the empty set, right? X can be any number such that it's in the empty set. So that empty set is like a 0 with a slash through it. That's the universal symbol for math to represent the empty set. And so sometimes kids just like to recognize that. However, you should recognize that these two things translate to the same thing, no solution. Okay? So, rule of thumb, wrapping it up. When you move over the bridge, we perform the opposite operation. When you simplify on the same side of the bridge, keep the operation the same. So that's a really good sentence there. And when in doubt, you can always check your work. I wanted to save us some time, so I didn't check our work in any of these, but you can always substitute that x back in, simplify the left-hand side, simplify the right-hand side, using order of operations, and see if they simplify. So you can see in the details the U-tries. There are 6 problems there, and I do have them spaced out because I know it does take a little bit of work. So hopefully you found that helpful. Please give the U-tries a try. And if you need help, remember there is a follow-up video that you can watch breaking down those 6 U-tries. And there is an answer key posted. So I can't wait to continue with our equations and keep up the great work.